Hello again everyone, welcome back to ptet.chemistry channel. So in this tutorial video, I will continue these topical MCQs on chemical structure and bonding. So this is from question 31 to question 35. As usual, this is a 5-question series, alright? So in this question, which molecule or structure does not, so they even bolded for you, contain 3 atoms bonded at an angle between 109 and 110. So we first off, we look at ethanoic acid. So I'm going to draw a display formula where I show every single covalent bond, including the OH covalent bond, in order to show the bond angles within, alright? So this carbon here is actually sp2 carbon. This is 120 degree because as you could see there's only 1 sigma because it's a double bond. It's 1 sigma and 1 pi, so it's 1 sigma, 2 sigma and 3 sigma. So this is actually a carbon sp2 hybridized with 0 lone pair because the carbon uses all 4 of its valence electron for bonding, and it's got 3 bond pairs, so it's a trigonal planar carbon sp2 hybridized. Alright, if I use another color, so this is 104.5 degree, so there is a 2 lone pair and 2 bond pair. So obviously we know that lone pair repel more than lone pair bond pair, repel more than bond pair. As usual, this is part of the explanation required by the valence shell electron pair repulsion theory, without which your explanation wouldn't be complete to explain geometry and also bond angle. Alright, what else can I say? This is a carbon sp3 with 4 bond pair and 0 lone pair. If you count the number of sigma covalent bond, there are 4 of them, and therefore this make it 109 degree tetrahedral. So most of the carbon sp3, carbon sp2, carbon sp hybridization, so they're all part of your required hybridization knowledge, not just in organic chemistry but also in chemical structure and bonding. So this one does not contain 3 carbon atoms at an angle between that and that. Does not contain 3. Well, there are 2 carbon atoms, so the first condition satisfied. You need it at an angle between 109 and 110. Sorry, you do not want it to be 109 and 110. This is the tetrahedral 109, so this is referring to is tetrahedral. But because of this, we are looking at is not tetrahedral, alright, because of this thing there. Alright, so I can tell you A is not what we are looking for. How about graphite? So in graphite you have a layered structure, so I'm trying my best to draw the hexagon layer. Of course it's continuous, as you would have known from your GCSE or O-level or IGCSE. So this is layers of graphite, where you have the weak van der Waals forces, which you need to write out in full. I can abbreviate, but not you in a real exam. So each carbon in the graphite structure is bonded to 3 other carbon. So each carbon is a sp2 hybridized carbon, meaning to say it's got 3 bond pair, which is 3 sigma covalent bond, and it's got 0 lone pair, but it's got 1 free electron per carbon atom, which allows it to delocalize this free electron per carbon atom along the plane. That's why they are very good conductor of electricity. That's why graphite can conduct electricity along the plane of the graphite. Alright, so does not contain 3 atoms bonded at an angle, so it is not tetrahedral. Okay, and it does not, all the carbon is just 120 degree, so it's trigonal planar 120 degree. So I'm pretty sure that this is what we are looking for, where there are no carbon with 109 degree. Okay, let's have a look at propane and silicon dioxide. So propane is a simple alkane like this. So each carbon you can see has 4 covalent bonds. So this carbon is 4 sigma covalent bond. So it's 4 bond pair and 0 lone pair. Same thing with this carbon, 4 bond pair and 0 lone pair. Same thing with this carbon, 4 bond pair and 0 lone pair. Each carbon is sp3 hybridized. When you have sp3 hybridized, you have a 4 bond pair and 0 lone pair. That is your 109 degree tetrahedral geometry, and automatically that rules out option C. And then well, they don't say 3 carbon atoms, so here you have silicon 4 oxide. Silicon 4 oxide is another key structure that you need to know how it looks like. So each silicon is bonded to 4 oxygen in this tetrahedral environment, because each silicon is bonded to 4 different atoms, 4 bond pair, which are 4 sigma covalent bond, with no lone pair because silicon is just below carbon, so it's another group 14 element. All right, so there's tetrahedral as well. And then each oxygen is bent because of 2 bond pair and 2 lone pairs. So 2 bond pair there, and there are 2 lone pair which I haven't shown, and each oxygen is bonded to 2 silicon. So each oxygen is bonded to 2 silicon, and in turn the silicon is bonded to 4 oxygen. So it's a giant molecular structure, something you would be expected to be able to sketch easily. Alright, so you got a mixture of 104 and 109 degree. That means you got something which is tetrahedral there, and therefore that is not what you're looking for. Alright, so it's quite a simple questions where it's mostly a factual recall, I would say, if you know the structure and you know what angle they have. But some of these structures, they can ask you to sketch out how they look like, especially for graphite and silicon 4 oxide, where they like to ask you about physical properties as well in theory paper, not just in AS level or A level, but also from your GCSE, IGCSE, as well as O level kind of questions as well, yeah? In this next question, so the ability of an atom in a covalent bond to attract electrons to itself is called electronegativity. So this is definition of electronegativity that you should know. The greater the difference between the electronegativity, the more polar is the bond. So you get a more polar bond when you have bigger difference in electronegativity. So these are halogens. These are group 17 halogen molecules. Alright, so if I have a number line like this, En for electronegativity, so fluorine is the most electronegative atom, obviously. So electronegativity is actually of an atom, not of a molecule. Alright, because if you look at this, it already specifies for you. You have a covalent bond, yes, between the halogen molecule, but the electronegativity is the ability of an atom, individual atom, to attract the electrons in that covalent bond towards itself. So fluorine is the most electronegative element, followed by chlorine, bromine, and iodine down the group, okay? So when you have chlorine and bromine would be this much. Obviously, I don't know the actual value, so this is just representative, qualitative representation of the electronegativity value. We're looking at this much difference. Chlorine and iodine will have a bigger difference, as you could see from this simple representation. Fluorine and chlorine is also just like one element apart. Fluorine and iodine, as you could see, fluorine and iodine is the biggest difference in electronegativity, and therefore, since that is the biggest difference in electronegativity, we will get the most polar covalent bond between fluorine and iodine atom, as you could see here. All right. In this next question, so we have to show the bonding in the ammonium ion. So in respect to this kind of additive covalent bonding or coordinate bonding kind of question, I would advise students to always try and draw the 3-dimensional kind of diagram first. So this is just the three-dimensional representation of ammonia molecule. Well, when I'm saying three-dimensional diagram, I don't really mean that you need to draw the three-dimensional diagram. You could have drawn just the display formula like this. This is what we call the Lewis formula representation, where we show the covalent bond as line, and then we just show the lone pair to complete the Lewis diagram. Yeah. So in terms of how we will represent the dative covalent bond, is that you will use the lone pair on the ammonia, on the nitrogen, to pick up a H plus which has no electrons, and we represent as the covalent bond being formed from the lone pair. The electrons, the two electrons in the covalent bond, gets donated by only one of the atom instead of equal sharing between the two atoms, and the positive charge gets transferred from the H plus to the central nitrogen. Now that the nitrogen has gone from forming 3 covalent bond where it's got no charge, and now it forms 4 covalent bond. That's why you have a plus charge. All right. The same representation can be made by using the Lewis formula type of representation. Of course, you don't get any information on geometry here, but you get the information from geometry here, where it has changed from 107 degree. It's got 3 bond pair and 1 lone pair, and now you count the dative covalent bond as a single sigma covalent bond. So it's got 1, 2, 3, 4 covalent bond, which are sigma covalent bond. Now you have no more lone pair because you use the last lone pair on the nitrogen to form the dative covalent bond, or what we call the coordinate bond. So this is now 109 degree. Going from trigonal pyramidal to a tetrahedral geometry, this is what happened when NH3 pick up a H plus and form NH4 plus. All right. So I can tell you that D is out because of this. The 2 electrons does not come from the hydrogen. The hydrogen is H plus, so it's go from nitrogen to the hydrogen, nitrogen to hydrogen, nitrogen to hydrogen. Your nitrogen is missing the electrons on the nitrogen there because your nitrogen only has 1, 2, 3 electrons. It should have shown the 2 electrons on the nitrogen, donating to that. So A is also out. And then this is the thing that is wrong with this, because cross refer to the hydrogen. Again, the hydrogen electrons are not being donated from nitrogen to hydrogen, leaving C as the only possible answer. We got 5 of the dots to represent 5 outer shell electrons from nitrogen. So nitrogen donate 1 of its lone pair to the H plus, resulting in this change in geometry and change in bond angle, as I've just explained, using VSEPR here. These are very common and popular questions, not just in MCQ, but also in structure and theory paper, where they ask you to describe and explain the change in geometry when NH3 picks up a proton or something like that. Yeah. In this next question, we have this unusual compound called methyl isocyanate. So in the methyl isocyanate molecule, the sequence of atom is, well, whatever that's shown here. What is the approximate angle between the bonds formed by the nitrogen atom? So this is what you want, this is what you want, this is what you want, and this is what you want, right? So we need to get started by counting the number of covalent bonds around the nitrogen atom. All right, we only count the sigma covalent bond for the lone pair, so it's got 1 sigma covalent bond here. This is a double bond, so in the double bond you have 1 sigma and 1 pi. Here you have 1 sigma, so altogether you have 2 sigma, which means 2 bond pair of electrons, 2 bonding pair of electrons. The nitrogen is in group 15. It's got 5 outer shell electrons. It uses 1, 2, 3 electrons for bonding. It still has 1 lone pair of electrons. The 2 bond pair and 1 lone pair would mean that you do not have lone pair because you only have 1 lone pair. So if you only have 1 lone pair, how can you have a lone pair repelling with lone pair when you only have 1 lone pair? All right. So it's just bond pair, lone pair, repel more than bond pair, bond pair. And this is an unusual geometry which you don't usually see in A-level textbooks, but this will actually give you a bad geometry, but it's 120 degree. So if you think this is unfamiliar, so think about think about something that you would have done in A-level or something you're about to do. All right, so SO2 molecule is a part of the contact process. Sulfur is in group 16. One sigma covalent bond, 2 sigma covalent bond, so 2 bond pair, and it's got 1 lone pair because sulfur is in group 16. It uses 1, 2, 3, 4 for bonding. You got 1 lone pair. This is also 120 degree based on what I just said, 2 bond pair and 1 lone pair. Something you have done from O-level, something you would not have done from O-level. All right, so we're looking at 120 degree because of the presence of 2 bond pair and 1 lone pair. Okay, as a result of it. Okay, just to relate to your SO2 molecule, which is part of your oxides of third period. It is something you will cover in general periodicity topic. All right. Okay, this is the last question of this 5-question series. So this is asking which element shows the greatest tendency to form some covalent compound. So there's something that is also not really in the usual textbooks, something called Fajan's rules. So we talk about more polarizing cations. Okay, so polarizing and polarization it will cause an increase in covalent character. So more polarizing cations will mean small cation, and you want highly charged cation. Okay, so I can tell you neon is definitely out because that is monoatomic noble gas particles. They just exist as monoatomic single atoms. All right, so among potassium, magnesium and aluminium, potassium has a +1 charge, magnesium likes to form the Mg2 plus, aluminium likes to form the Al3 plus. This is the 4th shell, but when you lose the 1 electron, it has a completely filled 3D the N=3 shell. So it has the electronic configuration of argon. This and this have the electronic configuration of neon, so these are smaller than this. I can cross D out. So these have different charges, although that this is actually smaller than this as a result of higher or stronger effective nuclear charge due to the higher charge being shown there. So Al3 plus. Okay, when aluminium form compound, when exists Al3 plus, you will have the greatest tendency to have covalent character as a result of the cation being much smaller, as a result of the cation being more highly charged, and therefore it become more polarizing cations, and therefore it will result in greater degree of covalency, meaning to say it will introduce more covalent character in the compound. Right, that's why the AlCl3, instead of being what we think it would be, being ionic, it is actually simple molecular. That's why it sublimes at low temperature to give you the dimeric Al2Cl6 in the gaseous phase. All right, so that's it for me in this 5-question series, and don't forget to click the button at the bottom right, subscribe to the channel, share the channel with friends, chat group, your social network, your juniors, your seniors from school, anyone else you think this channel might be useful for. Check out my other creator playlist on the channel, and I'll see you in the next video. Thank you for watching.